Okay, good afternoon. Okay. This is the webex 6 for jim211 Advanced Calculus. I'm Dr. Law. Okay, welcome to the webex sessions. And this will be the last webex for the jim211 for the academic year 2016 and 2017. And we still left one chapter that we need to settle by today. Okay, so the chapter 17. Okay, there are three sections. Okay, the 17.8, the cylindrical coordinates. The 17.9 involves the spherical coordinates that you need to solve the triple integrals. And the last section is the Jacobians. Okay, how we change the variable in the multiple integral. Okay, and then if we have time, then we will have some revisions. Okay, so the cylindrical coordinates, okay, we need to change the Cartesian coordinates x, y, z into the cylindrical coordinates r, theta, and z. And it's involved the relationship between x, y, z, and r, theta, z is x equals to r cos theta, y equals to r sin theta, z equals to z, and we replace the dv equals to r dr d theta dz. So, okay, please be careful, right? When we do the transformations, okay, from x, y, z to r theta z, dx, dy, dz equivalent to r dr d theta dz. There is a r here. Okay, in the last section, the Jacobian, we will show why there is r here. Okay, the last section, Jacobian, we are able to show that there is r because of the Jacobian. Okay, so this is the coordinates. When you have the point in Cartesian coordinate, this point, okay, this point, we may use the Cartesian coordinate, the x, y, and z. But now, the same point 3D here, we would like to represent using the r theta z. So the z represents the height from the xy plane. Okay, and when you project to the xy plane, the r represents the distance from the origin to the point when you project to xy plane, and the theta represents the angle from the x-axis. Okay? So please look at this example, the final exam, the question 2014-2015, the question 2D. Given the triple integral, okay, now you have the triple integral in Cartesian coordinate x, y, and z. And the limits of integrations represented by the A, the solid A. The solid A is given by these conditions. Okay, actually is the boundary, the solid here. So sketch the solid A and evaluate the integral. Okay, so the answer you should be able to obtain, the answer is 1014 pi. So the first thing will be how to sketch the solid. So you should be familiar with the surfaces. Okay, so before we actually, I would like to show some of the surface that you should know. Okay, the first one is the plane. Okay, the plane, you will find that it is linear, the x, y, z. Okay, the variation can be ax, by plus cz equals to d. for example. But this is the simplest form. I will put x plus y plus z equals to r. So that means you will have a plane that will pass by when y 0, z 0, you get x equals to r, and r. Okay? If there is no any conditions restriction, this actually is represent a plane. The plane that pass by x, y, and z at r. Okay, so it will be like slanted, the planes that pass by this, and then it will go beyond and go beyond x and plus and y. But if let's say this, they give you the plane and they mention that it is bounded by the coordinate planes. Coordinate planes means when x 0, y 0, z 0. Or in another word is the YZ plane, the XZ plane, and the XY plane. Because when Z 0, you get the below here, the plane. So when it is covered by these 1, 2, and 3, then you get the plane like this, the triangle here. Because, you are bounded by the X, Y, and Z, the 0, the planes. So you left only, the planes that is passed by here. If there is no this restriction, the plane will go beyond positive, negative, and slanted. The second surface, 3D, that we have is the sphere. Of course, you have an ellipsoid. Ellipsoid means it is not the round with the same radius from the origin. When you have x squared plus y squared plus z squared equals to r squared, so it means that you are getting a sphere with the radius from the origin to the surface is always r. This is negative r, negative r. So if you have the ellipsoid, it is not the distance from to x and y will be different, and to z will be different, and you will not get the round, the perfect shape. And then one thing, if the equation is x squared plus y squared plus z squared square root, then you will get the hemisphere, and because this is positive, so you will get the half sphere. We call it the hemisphere, and this is r. Because it's positive. If r negative here, that means you will get the hemisphere that is the lower beneath the xy plane. So this is the negative one. The other one is the cylinder. You will notice that if these equations, if it is in 2D, it represents the circle. The same equations, if in 3D, it represents the cylinder. So you must be careful when you look at this, it is in 2D or 3D. If in 2D, it's a circle with radius r. If it is cylinder, it is a cylinder with the radius r. So the cylinder here, if there is nothing mentioned, this is actually a cylinder. Remember, this cylinder is actually the surface. The surface here, the surface, and it is not covered. It represents the circle. This is the cylinder without nothing cover. So when you have to sketch the solid, normally the cylinder represents the surface here. It will be covered maybe by something up and something at the lower part. If not, it will be infinity up, infinity down, because there is no z here. So it's actually the cylinder is the surface, the curved surface, up and down. Okay. Okay. The next one will be the paraboloid. The paraboloid, the formula z equals to x squared plus y squared. Okay. So the shape will be like this. Okay. Why do I know that it is a point here? Because you will find that when x 0, y 0, z equals to 0. So it will be this point. And remember, again, this represents the surface, like the bowl, the surface. It is not cover. It's just this surface. Okay, this surface only. Okay, so the height of this formula is actually infinity to z. Okay, and it is not cover. So when you have a solid, there must be something cover upper part. Okay, there must be something cover under upper part so that it is closed. But if not, only these equations, it represents the surface that is you can go beyond to the x infinity. Okay, another one will be the z equals to r square minus x square minus y square. It will be the paraboloid that is in this form. And what is the intercept, z-intercept? You will find that when x 0, y 0, z equals to r squared. So this is r squared. And you will find that, okay, when you have the z0, okay, when x 0, y 0, you get z equals to r squared. So the z-intercept is r squared. But when you have z equals to 0, you get x squared plus y squared equals to r squared, and you get the circle with radius r. So this is r. Okay, the circle radius r. So compared to hemisphere, what is the difference? The hemisphere, this is r, this is r. So to be exact, this is actually the shape like this. Okay, this is r, but the height is r squared. Okay, this, okay, the paraboloid. And the last one, cone. The popular, the surface, the cone. Here, circular cone. Okay, this is the circular, the paraboloid, because here is the circle. Okay, when you put in x, y, okay, this is a circle. It can be in the ellipse. Okay, it can be in ellipse where, like this, ellipse. Okay, circular cone is the same. Okay, if you have z squared equals to x squared plus y squared, okay, you get actually cone. If only this, you will get the cone, actually the up and the down. Okay, unless they said the is covered by the xy plane, then you get only the positive. Okay, if not, the z squared equals to x squared plus y squared, you get actually the cone like this. Okay, if you want only the positive, the upper part, normally we will write in this form. Okay, this is the half cone that is represent this one. Okay, and this, when you project to xy plane, it is a circle. So that's why it's a circular cone. But it can be, if you have a constant here, the A and B here, then you might get the elliptic cone. We call it elliptic cone, where when you project the xy here is not circle but the ellipse. So it's just a constant that will give you the difference between the circle and the ellipse. Okay, so when you're familiar with this, then we go back to the questions. Okay, here, okay, when you have, this is in 3D, solid is 3D. So you have x squared plus y squared, constant 9 and 16. So x squared plus y squared equals to r squared is a cylinder. So this is actually cylinder in between the radius 3 and radius 4, because of 9 and 16. Okay, so we want to sketch the solid A. Okay, so this, when I have x squared plus y squared equals to 9, okay, x squared plus y squared equals to 16. This is actually the cylinder. One with the radius 3, cylinder radius 4. Okay, and the solid is the in between these R3 and R4. So when I sketch the first cylinder, okay, it should be 3, and it is actually infinity up and down. And then the 4 is very the scale. I'm not following the scale. I just want to make it clear. So 4 will be bigger, and another one. Okay, and now it is from Z3 to 4. So the cylinder now cut from 3 to 4. It is not from the Z0. Okay, 3 to 4. Okay, so for example, if this is 3 and this is 4, so it is actually covered from here, the cylinder, until here only. Okay, so it's a cut. The cylinder here cut 3 to 4. Left only this, bounded like this. But x0, y0. That means we want only x positive, y positive. Okay, we don't want the x negative. So x negative will be something at the back here. Y positive will be something that left here we don't want. So it left only in the first octant. When you divide, it will be the first octant only. If the first octant, that means, okay, here is the positive, negative we don't want. Here the positive, negative we don't want. The back. So what we have will be like this. Okay, so to be clear, okay, it will be something like at this level, the cylinder with radius R4 and 3. So in between. Okay, the solid will be in between, and it will cut here positive, positive. Okay, so if let's say if I draw it again, it will be something like the cylinder, the first part, okay, the cylinder for the second part, okay, so it will be covered from here, okay, and then here is the surface, okay, the cylinder like this. Okay, when you project to the XY plane, so we will get this is R3 and this is R4 here, and then cover. Okay, so this is project to the XY plane. So now, okay, we want to transform because it involves the circle, cylinder. So it's easier if we use the transform to the cylindrical coordinates, and we solve it using the cylindrical coordinates, the integral. Okay, so we know that x squared for cylindrical coordinate, x squared plus y squared equals to r squared. Okay, because x equals to r cos theta, y equals to r sin theta. So here we will transform this r squared 5/2 and dx, dy, dz, okay, represent with the dz, r, dr, d theta. Or you want to put r, d, dr, d theta, dz also can, Okay, no problem. Okay, the important is there must be an r here. Don't forget about there is an extra r here. And now, how to determine the limit of the integrations represents by the solid here. Okay, your z from 3 to 4. Okay, z from 3 to 4. R from 3 to 4. Okay, from the origin, R from 3 to 4. Theta, because your theta here 0 is only 90 degree. So theta from 0 to theta pi over 2. So, okay, it's a theta 0 to theta pi over 2. Is R3 to R4, Z3 to Z4. And simplify here, you get R power of 5. Don't forget R here. So we have R power of 6, dz, dr, d theta. Okay, and when you do solve it, you will get the answer. This. Okay. So try and see whether can you get this answer. Okay. Because there are quite a lot that we need to cover, so I will leave it to you to try, see whether can you get the answer. Okay, now we go on to the other one is the spherical coordinates. The spherical coordinates, you change from x, y, z to rho, phi, theta. And this is the formula that involves. Okay, don't worry, don't memorize the formula because this formula will be given during the final exam. Okay, and how do you transform? Okay, x, y, z using this, but look at here, the dx, dy, dz now. Okay, replace with rho square psi phi d phi. There is a d here. Okay, there is a d phi d theta d rho. Okay, or you want to put d rho d phi d theta also can. It depends on the limits of the integrations. The last one, the outer, the limit must be constant in order to get the answer. Okay, so this is the way that we represent. The same point, if in x, y, and z, when we represent using the spherical coordinate, the rho represents the distance from the origin. Okay, the distance from the origin. This is the rho. When you project to xy plane, the theta here represents the angle from the x-axis. The phi is the angle from the z-axis. Okay, z-axis. So you have found that for phi, okay, limited to 0 to pi only, theta from 0 to 2 pi, and rho must be positive because it's the distance from the origin. The distance. It cannot be negative. Okay. So let's look at these questions. The final exam for 2015-2016. Question 5C. Show that the volume of a sphere of radius A is 4 over 3 pi A power of 3 unit cube using the triple integral in spherical coordinates. Okay, so let's look at this question. Okay, the sphere with the radius A. So this is the radius A. So we would like to use the spherical coordinates in order to find the volume. Okay, the volume, the formula will be 1 dV. And if we want to transform using the cylindrical coordinates, the dV here is rho square sine phi d rho d phi d theta. Okay, so this is the dV. 1 remain 1 because the formula for volume, this is the volume, volume formula is 1 dV for triple integral. So now we want to determine the limit of integration. Okay, so this is for rho. Rho is the distance from the origin. You will find that for the sphere, whatever the surface from the origin, it will be always A. So it is from rho 0 to rho A. Okay. Phi from the z-axis, and you will find that it can be maximum phi from 0 to pi. So now, okay, the phi here, when this is the z-axis, it covers until the end. So lower part. So the phi is from 0 to pi. Okay, so what does it mean? It means that now you have 0 to rho. Your phi 0 to rho, 0 to rho, and your phi from 0 to pi. Your phi from 0 to pi. And this surface, okay, when you project, to get the whole sphere, you need to turn complete around to get the sphere. So theta from 0 to 2 pi. Because when you project, you need to cover all to get the whole sphere. Okay, if your sphere, okay, if it is hemisphere, then rho from 0 to A, phi from 0 to pi over 2, your theta 0 to 2 pi, because you are covered until here and you turn the whole round. Okay, so if this is only here, okay, the quarter only, so your rho 0 to A, your phi 0 still to pi over 2, but now your theta from 0 is only here. Okay, only here, the first part, it will be pi over 2. So it depends on the solid. Okay, so by using this, okay, from 0 to rho 0 to A, phi 0 to pi, theta 0 to 2 pi, at the end, you will get the answer 4 pi over 3A cubed. This is the volume of the sphere, and we have proof it. Okay, so try, see whether you can get or not this answer. Okay, so move on to the next question. Okay, this is the final exam question 2011 to 2012. Okay, question 2B, number 2, sketch the cone. Now you need to sketch the cone. Okay, and then this cone is x squared plus y squared less or equal to 3z squared. Okay, this is a circular cone, the circular cone. And then z from 0 to 1. Now it is only the upper part, because your z is only positive. Okay, although it is not put the square root there, but because of this, so it is at the positive, the upper part of the xy plane. And then evaluate 1 ds dy dz. The answer is pi. Okay, now let's sketch the cone first. Okay, so the question, x squared plus y squared less than 3z square and z from 0 to 1. When z 0 to 1 means your surface, you're covering with the surface. This is the z0 until 1. So the level is until here. So you have something, the plane that cover from 0 to 1. Now your cone, the shape of the cone, we know that it is like this. But now we need to determine, because there is a constant 3 here. If there is no, okay, so now this is your cone. Okay, the cone that is from 0 to 1. So the level here, the height from here is 1. Okay, the height, because z equals to 1. Okay, z equals to 1 here. The plane, z equals to 1, z equals to 0. Okay, so now when you project, how this is a circle or elliptic? Look at here, the question here. Okay, if I divide by 3, okay, divide by 3, that means x squared over 3, y squared over 3, and z squared. Okay, and when this z squared, the 3 here, if I want to put in the square here, so it will be z3 square, z3, and z square. Actually, okay, when z equals to 0, I will get the form of the here. Okay, when I project here, okay, I will get a circle with the is a circle, is a circle, because here A and B, there's the same value here. So it will be a circle, but now with the radius 3. Okay, 3 because of this. Okay, it's not the ellipse, because the ellipse, the value here will not be the same. Okay, so okay, if you cannot imagine this one, you may look at the circle actually contribute from here. This is when z equals to 1. So when you substitute z equals to 1, okay, you get x squared plus y squared less than 3. So this, that means at level z equals to 1, you get the circle with the radius 3. So this is actually represents this circle. Okay, because when z equals to 1, you get the circle with the radius 3. Okay, so this is the cone. Okay, this is 3. So you have this. You need to sketch the 3D and the 2D. Okay. Okay. Now we would like to solve the question z from 0, 1. Okay, the question is to solve this, but we would like to use the spherical coordinates. So the dx, dy, dz replace with rho square sine phi d rho d phi d theta. Okay, so now the question, rho is the distance from the origin. Be careful, rho is not 0 to 1. Rho is not constant 0 to 1. Why? Because if you put 0 to 1 means any directions that you from here will be 1. Okay, will be 1. So you should get the circle like this. But now, the distance from here to here is 1. Distance from here to here is not 1. It's longer, maybe greater than 1. So what is it will be not a constant, it will be a function. Okay, because the distance from here to the surface here is not 1. Only the orthogonal, the straight line here is 1. So refer to the cylindrical coordinates here. Z equals to rho cos phi. Okay, Z equals to rho cos phi. In our case here, our z is equals to 1 at this level. So we need to find what is the distance to z equals to 1. So when z equals to 1, I found that the distance rho depends on the angle phi. Rho equals to 1 over cos phi. That means if I have here, I have 1. Okay? If I have here, it depends on the phi here to get the distance. The distance rho here depends on another phi. So it is a function that depends on phi. So our rho is from 0 to rho 1 over cos phi. Phi is from the z-axis. And now, your phi actually starts from phi 0 to this phi. What is the angle here? We need to find what is the phi here to get this. Okay? How? Look at here, the triangle. This triangle, the distance, the height is 1. And remember, this, the edge here, the circle, the x will be 3. So, we can find the phi here easily because we know that tangent phi will be 3 over 1. And the phi is the pi over 3. Okay, 60 degree. Tangent 60, you get 3. So, the phi is pi over 3. Phi from 0 to phi pi over 3. And this cone cover all from positive, negative, and then so theta will be 0 to theta 2 pi. Okay, so the phi 0 to 1 over cos phi, phi 0 to phi pi over 3, theta 0 to 2 pi. Okay, at the end, you will get the answer is pi. Okay, when you get the answer is pi. Okay, so you will, in the middle of the case, you will need to use the trigonometric substitution. No. The normal substitution, sorry. The normal substitution. Okay, that's why JIN 101 is important. Because in JIN 101, you learn the techniques of the integration. Okay, one of it is the substitution. You are going to use the substitution u equals to cos phi. Okay, in this case, when you solve in the middle of the calculation, okay, you need to use the substitution, okay, to get the to solve the integration. Okay, so this is the spherical coordinate. Okay. Now we move on to the last section, the Jacobians. Okay, the changing variable in multiple integrations. So the original in x and y. Now we want to change to, let's say, u and v. Okay, there is a Jacobian that you need to find the derivative del x del u, del y del u, del x del v, del y del v, and you solve the determinant. Then this is the Jacobians that involve. Okay, so you will learn more in calculus vector. But this is involve 3 variables. X, y, z change to u, v, and w. Then you are going to have the 3 by 3 the Jacobian that you need to solve the determinant, and this is the one. So let's look at the simplest, the easiest one, the polar coordinates. Okay, remember the polar coordinates here. Okay, let's okay, here. Okay, what is the when we want to change the coordinates? The normal that we know is we use the Cartesian coordinate. Cartesian is like the block, the straight line. Okay, if I have a point here, I can represent using the Cartesian coordinate, where the x here represent actually, okay, the distance here, x, and then the height is y. So the x and y goes to this point. Okay, now the same point, okay, we want to represent using the coordinate r theta. This xy represent this point, the r theta represent the same point, but they use the different measurement. Okay, the different measurement. So the measurement for xy is the distance from the x and y, and it is straight line. Okay? R theta is using the distance from the origin to the point. The distance from the origin to the point represents the r. Okay? And theta represents the angle from the x. So the theta here, so you get the point. Okay? The point here. So when we want to represent the relationship between xy and r theta is the first one we know by the Pythagoras theorem. Okay, we know that the Pythagoras theorem, if you have the triangle, okay, we know that this is the x, this is the y, so x squared plus y squared equals to r squared. Okay, from the Pythagoras, we know this. So we get the first relationship. Okay, the second one, we know that in the trigonometry, that if I have the cos theta is x over r. If I want to find the sine theta is y over r. So I get the next relationship, x equals to r cos theta, y equals to r sine theta, which is the next one. Okay, if I want to represent this point, it's actually, okay, the x will be r cos theta, r sine theta. Okay, so when I have something, let's say the dx dy or dy dx, okay, so the function, the functions here in x and y, okay, when we want to transform the multiple integral, the function x and y is now changed to r and theta. Okay, the function x and y change to r and theta. But this r and theta, if you want to, in terms of r and theta, but how does it transform? We know that x is r cos theta, y is r sine theta to transform it. But dx dy, it is not straightforward dr d theta. It is not straightforward, but okay, it depends on a Jacobian here. The Jacobian of the xy or Jacobian of the r theta. The Jacobian. That's why you have the formula like this. Okay, when you exchange, okay, there is a Jacobian here, and then dr d theta. Okay, so how to obtain the Jacobian here? Okay, this Jacobian. Okay, so we know that x equals to r cos theta. So del x del r cos theta, del y del r, del x del theta, del y del theta. So when we find the Jacobian here, okay, the Jacobian, so the cos theta, sine theta, negative r. Okay, the determinant, cos theta multiply r cos theta, we got r cos square theta minus this multiply with this, because of minus negative you cut plus r sine square theta. And from the trigonometric identities, we know that the cos square theta plus sine square theta equals to 1. So you left only r. So that's why when you transform to the polar coordinate dx dy, you will get extra r because of the Jacobian r here. Okay, the same method when you solve for the cylindrical and the spherical coordinate. The spherical coordinate, the Jacobian that you are going to obtain is a rho square sine phi. Okay, rho square sine phi. Okay, so I think that's all for the chapter 17. We have covered all the content for the JIM 211. Okay, I'd like to let you know that if some of you have already aware that I have uploaded the solution for assignment 2 and the marks for assignment 2. Okay, if you would like to get back your assignment 2, you can come to USM and please make appointment before you come. Okay, then the revisions, okay, for the chapters, we cover all 5 chapters in the final exam. Okay, you are going to have 5 questions. Okay, 5 questions solved in 3 hours. Okay, there are a lot of questions. 5 questions, A, B, C, D, and then A maybe 1 and 2. So there are a lot the questions. So you don't waste time. You cannot do the first question, then you jump to the next one. Because some may be easy, some may be need some time to solve. Okay, the chapter 11. Okay, please focus on the sequences, the monotonicity, and find the boundedness of the sequence. And the indeterminate form, the L'Hopital's rule. There are many types of the form. So I will not let you study all, but only one will come out. Okay, the improper integral. Okay, the way that you put the integral. Okay, and then the chapter 12, the convergence test. You should know which test is suitable. Okay, we will not tell you do which test. You can use any test, but it will be able to show is a converge or diverge, the correct test. And then the alternating series also, the absolute convergence and conditional convergence. Okay, because it will cover actually embedded in the power series here. Okay, the Taylor polynomial in x minus a, the power series, how to find the interval of convergence. Okay, the partial derivatives, find all the order, the first order, second order, the partial derivative. Okay, so it will be like you have a del over del x, del square over del x squared, all that, del x, del y. And then 2 path tests for non-existence of a limit. That means how to show that the limit does not exist. And then this is I have covered. You should know how to sketch the surfaces. Just now I've covered already. Okay, and then the chapter 16, the chain rule. Okay, and absolute extreme values. Okay, you found that in order to get the absolute extreme value, you should know about the local too, the local extreme value. Okay, so you still need to study the local extreme value in order to solve for absolute extreme value. So this is more difficult, but this is the one that will come up. Okay, and then the maxima and minima with side conditions. Okay, normally we will use the formula the Lagrange. Okay, the Lagrange. Use this is easier. Lagrange compared to the cross product. Okay, the Lagrange, the formula. Okay, the double integrals. That this is the most that cover. Almost if 3 questions, 2 questions from the integrals. Okay, one is double integral, the other one is triple integral. So these two questions come from this chapter. Okay, you need to know rectangle region means the limit of the integrations all are constant, a, b, and c, d. Okay, the dA. Okay, when you have type 1 or type 2, that means this is not constant. Okay, you have a function. And then you should know how to convert to polar coordinates for double integral. Okay, triple integrals is a normal triple integrals in Cartesian coordinates. And another question in cylindrical coordinates, and another question in spherical coordinates. Okay, some formula will be given. Okay, the list of formula that we will give you is the Taylor's polynomial. This is to get the extreme value, the local extreme value, the formula. This is the implicit differentiations. I give all. Okay, not all will be using. I give all, but not all you will be used in the final exam. This is the total differentials, the differentials. This is the gradients. This is the Lagrange for the maxima, minima, the set conditions. This is the polar coordinates. And of course, if you convert to the cylindrical coordinates also, they will be the same. And this is the spherical coordinates. Okay, this formula you may download from the e-portal. I have uploaded under the topics webex 6. Okay, I think that's all I have covered. Okay, for this webex, the last webex. Thank you very much and good luck in your final exam. Okay, any questions? Okay, you are welcome, you all. Okay, so if you would like to solve the questions, okay, you may post to the portal, okay, forum, discuss. If you don't want to post to all your friends to look at it, you may email to me. Okay, I will mark and I will comment and I will email back to you. Okay, so thank you. Okay, please do the revision. Yes, I will guide you all. Don't worry. Okay. Okay, thank you very much. Okay, I'm very happy if you all email or ask the question. But please try to do it first, and then let me and I will comment. Okay, don't simply ask how to solve it. Give the question and ask me to solve. You at least try. If you can't get, at least you try, and I will see. Maybe the starting part wrong a little bit. Maybe if the concept is wrong. So at least you learn from the mistake. Okay. Thank you very much. Bye.